I want to show you another way that we can identify the block size. The first method we analyzed was based on the fact that we knew the slash notation. So since we know the slash notation, it's just a matter of counting the number of bits. So it's as easy as saying, all right, we have 8 and 8, that's 16, plus 17, 18, 19, 20, 21, 22, 23, then that would be a 0, and then everything would be a 0 there. So since they gave us the slash 23, it's easy to work it out this way. But what if you were provided the dotted decimal notation? Well, if you're provided the dotted decimal notation, now's a really great time to use this method instead. So this method is all about taking this magic number of 256. Now, why is it a magic number of 256? What's it all about? Well, it's the maximum number of values you can have in any given octet. So we have 0, which could be a value, and the highest number can be 255. So how many values is that? That's 256 total IPv4 addresses within an octet, 0 to 256. Or sorry, 0 to 255. So that is 256. So now take 256 and subtract from that the most significant octet. So essentially, where you find the very last one in binary. But if you recall, subnet masks have to be contiguous ones followed by contiguous zeros. So we know that a 255 is all ones. A 255 is all ones. A 0 is all zeros, which means that the very last one, without even having to figure anything out, would have to be in this third octet here. It would have to be in the third octet. So as a result of that, take that value and subtract from 256. And we get a grand total here of 2. So what this means is we're counting by 2 in the third octet. So what are the numbers now in this case based on our example? We have 0, 2, 4, 6, 8, and so on and so forth. So we're counting by 2 in the third octet with our new subnet mask of a slash 23. Let's go ahead and do another example. I'm always a big fan of doing multiple examples. It's the best way to learn. So let's just go ahead and throw out any number possible here. So we're going to go ahead and use, let's say 10.1.1.0, and the new subnet mask we're going to use is a slash 26 as an example. So in this particular case, with 10.1.1.0 slash 26, we want to figure out what the block size is, and we want to identify what our subnet IDs are. They gave us slash 26, so in reality, what am I going to do? I'm just going to go 8, 8, 8, that's 24, plus 2 is 26. So I already know my block size is 64 based on our earlier example. But what if you weren't given slash 26? For example, in this case, let's say we are looking at the output of our router, and by analyzing the output of the router, we see this instead. So we don't see slash 26. Instead, we see 10.1.1.0, 255, 255, 255, 192. Well, in this case, this is going to be the perfect time to use our new shortcut. So 256 minus 192, and what does that equal? What does that equal? Well, 6 minus 2, last time I checked, was 4. Yeah, I don't even have to take my shoes off for that one. And then 25 minus 19, or if you want to go the 2, the 1, the 15. Ooh, that's a nice little 6 there. So 64. So the block size is 64. So we're counting by 64 in what octet? Well, going back, we know that 255 is all ones, all ones, all ones, which means that it has to be the fourth octet in this case, because 192 is going to have some ones in it. So we're counting by 64 in the fourth octet. So if we do the math now on that, the first network is 10.1.1.0 slash 26. And then we have 64. And then we have 128. And then we have 192. There we go, as an example. So those would be the various network IDs, and then we'd be able to identify who lives where based on that information. One more example, just so you can get a better feel for this new shortcut method that we're showing you. Again, I'm a big fan of using the one that makes sense at that time. So if I'm given slash notation, I'm going to use the slash notation shortcut example of finding the block size. If I'm given dotted decimal notation, I'm going to use the 256 option that we see right here. So in this case, let's go with something like 192.168.0.0, and the subnet mask that's going to be utilized is 255.255.255.240. So now let's go ahead and figure it out. It's as easy as saying, all right, so we have 256 minus 240, and that's going to give us a grand total of 16. So I'm counting by 16 in the fourth octet. So 16 in the fourth. So let's go over here, and the first sum that ends up being 192.168 dot what? 0.0 slash, let's convert it. What is that? What is that? It's 28. Good job. So slash 28. And then what do we want to do after that? Well, we're counting by, we said, 16 in the fourth. So now the next one's going to be 16. And then 32. And then 48. And so on and so forth. So there you go. If you're struggling with block size, pick one and practice it over and over and over and over again. Either go with the binary one or go with this one here. Just pick one and use that one every single time, which means that if you were given dotted decimal notation, you have to convert it to slash notation. And if you're given slash notation, you might have to convert it to dotted decimal notation in order to use the method you want. But if you can learn both, then you're going to become quicker, more efficient at identifying block sizes, because you won't have to do the conversion at that point in time. You just look at it, identify it, or look at it, identify it, and do the math from there. So pick one and become very proficient with one of them. And then once you're very proficient with one of these, then learn the other method. So 2 different methods for finding the block size. One is basically finding the decimal value of that binary bit position. And the other one is magic 256. Subtract 256 from the dotted decimal number.